Okay, so let's get started with functions. So the best way to describe a function is a process that calculates something. And the process, you might want to give it inputs for it to calculate something. And then when it's done, you want it to spit out the results. You want to receive that result and do something else with that result somewhere else in the code. So let's and defining a function. You start with def, okay, to define the function. And there are other types of functions with asynchronous, or some of them have decorators above them. But we're just going to work with a standard function for our purposes, and maybe later we might get into it. But let's create a simple one. Just add numbers, like a variable, except instead of assigning it to something like equals 1, you actually just put in an open parentheses and close parentheses. Just these two. And whenever you see these paired parentheses, it means call. Call, like go execute this, go do this. And you'll see this in a few moments. So and then there's a colon after the open and shut parentheses to indicate that we're creating a new indent. We're going to work within the scope of this function. If you started from here, there would be nothing in the function. Right? If I did that, it's the same as if I did this down here. So we're going to indents, and this is done automatically if you hit enter here. And we're going to say A is equal to 3, B is equal to 5, and then we're going to define C equal to A plus B, and print C. So now we're going to try running this code, and you'll see that nothing happens. And that's because we're not calling. You need to go down here below the function, not above, because it'll be undefined. You go below it, since Python reads top to bottom. You state the name of the function followed by this call kind of operator. And what this does is this calls the function. So as the code runs, it reads the defined function, works downward, sees that it's being called, goes back up, and actually runs the process, the function. And you'll see down here that it did print C as 8, which is A plus B, 3 plus 5. Okay, so typically you won't have, I mean, you could, but usually you won't always have constants. And constant just means you'll have it defined already. You'll have the user, you want to present the process to someone else and say, hey, try this out. So they want to use their own numbers. They want to use their own A and they want to use their own B. Your program should be flexible to accept arguments from inputs from any person, or, so what we do is you can technically define A equals 2 here, B equals 3, and you'll run this and it should work. There are scenarios where it won't work, and you might have to declare it as global, but we won't get too into that. But when you want someone to be able to input into a function, you have to define them within the call. So this is basically saying the add numbers function is supposed to receive 2 inputs, and whatever 2 inputs it receives, there must be 2, and I will declare the first one A and the second one B, whatever they are. So if I run this, of course, we don't have A and B defined yet. So missing 2 positional arguments when calling. There's no A and B here. So let's define A and B. I think we did 3 plus 5, right? So A and B is 3 and 5. And then we're going to pass A and B here. So now the function is prepared to receive A and B. And when the function is called, it sends the 2 inputs of A and B. So when we run this, the function will work. It will print C. And you could even remove the variables entirely, or yeah, you can remove them entirely and just put 3 and 5 within the call, and that will work. Or you can even rename the variables. My number 1 is equal to 3, my number 2 is equal to 5, and we'll put this here. And when you run it, you'll see that it works just the same. Because even though these variables are differently named than what it's prepared to receive, it only translates the value within. So literal 5, literal 3, or ints 3, ints 5. Okay. What's something else? So similar to having the function be prepared to receive arguments or inputs and calling the function with arguments and inputs, sometimes you want to return the calculation from the function. So instead of printing C, we can do what's called returning the value of C. You can return C. And what this does is, and I'll change this back to, I'll make this a bit easier to look at, easier on the eyes. So let's call the function with 3 and 5. The function's called, it takes 3 and 5. C is defined as 3 plus 5, and then return C. So what does return do? When you call it, it doesn't print anything. It doesn't seem to be doing much. What returning does is it makes this call almost like a variable. And when you say results here, you can call it results. You can say the sum of numbers. You can call it whatever you want. I'm just going to call it results. And what this does is it assigns, maybe I'll call this sum of variables. What this does is you're assigning a variable to the value of whatever returns from the function. So add numbers is called, and now at the end of the function, if it returns, which it does, it now becomes a value. So this becomes 8. You call with 3 and 5, it runs and it becomes 8, like that. Okay, if that's a way for you to help you understand the concept. So now instead of printing within the function, I can just print sum of variables. We can even call it sum of inputs if you prefer, since these are technically inputs, they're not variables. So now we'll get the answer 8, and this is what clean, simple but clean code looks like. And one of the reasons you would also use these and not define it globally is, let's say you had another function called subtract 1, and it only takes one argument. We'll just call it a number. We could call it C, but I don't want you to see the letter C too many places and get distracted. So let's have a function called subtract 1 and have it receive an input. And when that input's received, we're going to define it as a number, excuse me. And what we're going to do is we're going to take, we're going to say results is equal to a number minus 1, and we're going to return the results. So what I want to do is I want to take the sum of the inputs, which is the results of add numbers, which is going to be 8, and instead of printing it, I want to now call subtract 1 with sum of inputs, the results of add numbers, and I want to subtract 1 and return that result and print the second result. So let me just show you. It might be better than the way I just explained it. So let's call this subtracted 1, or subtracted number is equal to subtract 1, and we're going to set the input as the sum of inputs, if you're following. And maybe I'll separate this to make it easier. So if we run the code, we'll walk through it together. So a function add numbers is defined with inputs a and b. It returns c, which is the sum of a and b, which we define here when we call the function. The results of the function, c, is returned and assigned to sum of inputs. Sum of inputs is then used here in the subtract 1 function. Sum of inputs is used as an input to the subtract 1 function. The subtract 1 function takes that input, subtracts 1, and assigns that to a variable called results. And then we return results. When result is returned, down here, after we call it, and result is returned, it's assigned to this variable called subtracted number. And if we print subtracted number, we should get, so this one's going to be 8 because we do 3 plus 5, which is 8. And then this one's going to be 8 minus 1. So we should get 7 when we run this code. Yep. And that's pretty much it for functions. What else can I do? Let's see if there's anything else. I mean, you could do like a for loop, just a simple for loop. Let's do from 0 to 10, or you don't have to define 0 if you're starting from it. And let's do subtracted number, or no, let's do subtract 1, or subtracted number. Let's just copy and paste this, and the print statement. And since this is a new scope, we need to indent. And let's get the number 8 from the sum of inputs, and let's subtract the number 10 times. So let's go. Let's run this. And you get, oh, strange. Subtracted number is equal to, okay. So the reason this happened is because, and this is a good thing to go over, for I in range of 10, subtracted number is equal to subtract 1 sum of inputs. Print subtracted number. It does the same thing 10 times. Sum of inputs never changes. It is always 8. It's 8 here and it's 8 here. That never changes. What we should do is say sum of inputs is equal to, so we redefine sum of inputs as the results of subtract 1 with the input of sum of inputs, and we print sum of inputs. So now when we run this, we'll see it does decrement, and it goes from 7 to -2 because we start from 8, and we do this 10 times. So I think I'm trying to think of something else I could show you, but that should be enough for us to get started. Another thing might be imports. So let's say we import random. That's one of the native functions that come with Python. For AlgoLearn, you will have to pip install functions. So you do pip install Python algo SDK. Actually, I believe it's py AlgoLearn SDK, but I'll have to double check later. So once it's installed, you'll have access to all the AlgoLearn imports and functions. But for now, we're just going to import random, which again is native, comes with Python. And let's say, let's remove this, or let's Control Z. Okay, and remove that. Let's import random again, since we Controlled C that out. And after we get the subtracted number, let's say random number is equal to random dot rand int. And I guess we should go over classes now. Um, so random is a class, or actually random is the module. Random is the module. Randint is a function within that module that we can use. So we don't have this function randint in our code. We have add numbers and subtract 1, but we can import this function that was already created for us by someone else, so we don't have to write it out again, and use it in our code here directly. So we access the module, and then we access the function within it with this period to indicate we're going somewhere inside the random module. So we're going into the randint function from the random module. And let's see what else exists. You can hit dot and you can see they have rand range, rand int, choice, beta variate, choices. There's a bunch of different ones. So we're just going to use rand int. And rand int expects two inputs in range of A and B, including both endpoints. So this means that if I say 0 to 10, this will give you a number between 0 to 10, including 0 and 10. If I use rand range, it would give you somewhere between the stop and end range. So I believe it would never give you the end range, so you would never see 10. And you can also define steps, so like 2. So this means you will only get an interval of 2 between 0 and 10. But I think we're going too much into random rand range and how that works. So let's just print random number. And let's print subtracted number plus random number. And now we're using three functions to get a final number here. So we get 7 when we print here, or here. So subtracted number is going to be 8 minus 1. And then here, random number is going to be 6. So it gave me a random interval of 2 between 0 and 10. It chose 6. That's just what it chose. And here, we take the subtracted number, which is 7. You can highlight to confirm. And this random number, which won't be defined because it's always random, but we know it's going to be an integer. And we add them together, and we get 13. So 6 plus 7, 13. And if we run it again, we'll get a different output for random number and subtracted number plus random number. So it gave us 0, which is the starting point. And we're going to go more into, well, I could go into it now, classes. So a class is basically, you define it as class. And let's say I'm a fan of video games, so let's say Goblin. And similar to a function, you end it with a colon, but you'll notice it's yellow, it's green instead of yellow. And of course, it's defined as a class when you hover over it. So what is a class? So a class is something you instantiate in your code. So it's an object. It's something like a person or a goblin, or maybe an instance of a process, or it can even have functions within it, which are called methods. So let's say class goblin health is equal to 10. I guess we'll add in attack. Why not? Attack is equal to 2. And let's create a function within it called decrement health by 1. And here we'll just do health is equal to health minus 1. And that's it. So now let's try it out. So let's print goblin. And this will not do anything. It'll print an object, I believe. Yeah, class. So what we have to do is create a variable, say myGoblin, is equal to, similar to functions, we call an instantiation of the class goblin. So we're creating a class, we're creating an object, and it's an instance, a copy of this class. And I'll show you later that they're not connected directly. It's an instance. But if we print myGoblin now, so previously it said class main, now it says goblin object. So it's an instance of goblin. So goblin has two attributes, health and attack. And then it has a method called decrement health by 1. So similar to how we accessed in the random module functions within the random module with a period, we'll do that here. So myGoblin dots, and then you can see what goblin offers. Ignore anything annotations and after. This is just native Python tools that you likely will never use. To be honest, I don't use most of these. So except for maybe this one. So myGoblin.health, let's print that, and print myGoblin dots attack. And we won't print decrement myGoblin dot decrement health by 1, but we will call it instead. Similar to a function, we'll call it, and we'll print myGoblin health again afterwards. So let's run this. We'll get the attack, the health, which is 10, the attack, which is 2, and what's going on here? Decrement health by 1 takes 0 positional arguments, but 1 was given. That's weird. Line 15. Oh, excuse me. So we need to define self, and we need to say self.health is equal to self.health minus 1. So I believe that should work. Yeah, perfect. So self, it's a tricky concept to explain, but it's basically how you reference how an instance of the class references itself. So myGoblin is an object of the defined class goblin here, but it needs to have it needs to pass itself into the class to access the function, which takes the input as the object. And again, it's a very difficult concept, but accepts the instance of the object and then performs whatever action, likely on itself. So here it's accessing the attribute of health of the goblin, but not of the class goblin, of the instance of myGoblin here. So you'll see it printed 10 because it starts with the default health of 10, and it printed 2, default attack of 2, and then it printed 9, which is the health of this instance of a goblin subtracted by 1. So if I do a second goblin, new goblin, and I could even do it here right after the other one, second goblin is equal to goblin. The class goblin, an instantiation, we're calling an instantiation. And then if we print second goblin dot health, you'll see that myGoblin still has 9 health after decrementing, but second goblin does not have this change. So it still has the original value. myGoblin was decremented, its health was decremented by 1, but the second goblin, its health was not decremented by 1 because it's a separate instance of the class goblin. Instance, object. Keep those in mind together. And then a class is completely separate from those two things aside from creation. Um, so yeah, I think that covers it. And we're going to move on to the next chapter. Good luck.